In this video clip, let's look at the law of sine. Sine is the opposite side in a right triangle over the hypotenuse. If you look at the triangle B, C, and this vertex, B, C, and this vertex is actually a right triangle. So H over this side, A, is the sine gamma, H over A. Then you know both sides multiplied by A. You may cancel the A with the bottom A. You then have a H on the left-hand side, left alone. So you then have A times sine gamma. That's in the first triangle. In the second triangle, if you look at C, B, and this vertex, so you have a H over A is sine gamma. So H over A again is sine gamma. Again, both sides multiplied by A. So you then have is H equals A times sine gamma. So in either this triangle, first one, or the second one, you always have H equals is A times sine gamma. So that's important. Now, let's look at the sine alpha in this case. In the middle triangle, that's the one right here, we have this triangle B, A, and this vertex. Let me choose different color. B, A, and this one. So you then have in this right triangle, H over C is sine alpha, opposite side over hypotenuse. Previously, the opposite side was here. Hypotenuse was here. That was for gamma. Now the opposite side is H. Hypotenuse is C in this triangle. So you then have a sine alpha is H over C. So in this middle triangle, again, both sides multiplied by C. You have these two C cancelled. So you have H left alone on the left-hand side. Right-hand side is C times sine alpha. Okay. So that's for the middle triangle. Now, if you look at the left triangle, look at these three, B, A, and this vertex. And then you will have look at this angle sine pi minus alpha, because this is alpha. And sine pi minus alpha is this angle. Okay. So H over C is sine pi minus alpha. So you then have a sine pi minus alpha is h over c. Is again h over c is sine this angle pi minus alpha right here. Again, then both sides times c. You have these two c cancelled. So you have h equals h alone equals c times sine pi minus alpha. Okay. For sine pi minus alpha, there is a property previously we learned, which is actually equals sine alpha. That's the special for sine. Okay. So basically what we get here is c times sine alpha again for h. Okay. Now see, in either this case, middle triangle, or in this case, the triangle looks like this. Alpha here was acute. Here is obtuse. Okay. It's greater than 90 degrees. Here is less than 90 degrees. Acute triangle. In either these two cases, we have a h equals c times sine alpha, and h equals c times sine alpha. All right. So then you see, consider the first case, which is this case, is h equals a times sine gamma. And then in the second case, we have also h equals c times sine alpha. You see right here. And then, you have a h, the first case, and h, the second case. Those two cases are the same. Third case, these two cases are the same. Okay, so you have actually h equals a times sine gamma. Okay, so you then have a h right here is a times sine gamma. First case. You also have h equals c times sine alpha. Okay. Second and third case. This basically tells us a sine gamma equals c sine alpha. Okay. So in this case, if I write it here, that will be a sine gamma, and then c sine alpha. Then what I need to do is both sides divided by AC. And then if you cancel this C with this C, this A with this A, so what you get will be what? Will be this one right here. Okay, that will be sine alpha over A is from here equals sine gamma over C right here. This tells us what? This tells us, sine alpha over A in this left triangle, the first left triangle, alpha is the one right here. So sine alpha divided by this opposite side equals what? Equals sine gamma divided by its opposite side, c. Sine gamma, you see right here, divided by the opposite side of c. Okay, that's a very important property, and so is in this case. Sine alpha is here. You see, this is sine alpha divided by the opposite side, a, right here, equals sine gamma, gamma is this side, divided by the opposite side of c, like here. Okay, so that's a very important property. Similarly, readers can prove sine alpha over a, sine alpha over a, that's one of these, actually also equals sine beta over b. Yeah, that's the angle we didn't touch, but you can do that. Because we have considered these two different cases, this case and this case. In those two cases we have considered, because alpha, one is greater than 90, another is less than 90. There are two cases we have proved. So sine alpha over a, that's again sine alpha over a is also equal to sine beta, this angle, sine beta divided by b, this side. Okay, so you may also choose the different one. Sine beta over b, that's the one right here, to prove equals sine gamma divided by its opposite side. Okay, so if you proved either one of them, you then can put everything together. What you can do is that you can put everything together. That will look like this. That will look like this. This will be called the law of sine. Okay, which is very important. Is always sine one angle divided by the opposite side equals the other sine of that angle divided by its corresponding opposite side. So easy to remember. Okay, upstairs they are all sine values. Downstairs is the corresponding sides. Okay, so that's the law of sine. You may wonder that, how about if the triangle is a right triangle? You may wonder about that. That would be easy proof. Okay, so you see, in this right triangle, we have a over c. A over c is sine alpha, right here. And we have a sine beta. Sine beta is b opposite side over hypotenuse. Okay, so then what do we get? We then have a c downstairs. C downstairs. So for example, here you have got to be, yeah. You have a sine alpha, this one, equals A over C. And then you do is you may multiply C on both sides. You cancel this C with this C. And you can do more is then divided by sine divided by sine alpha. Okay. Divided by sine alpha. So what do we get? We then get is those two will be cancelled. So C equals A over sine alpha. Remember, there is a 1 downstairs. If you flip numerator and denominator at the same time, so you have a 1 over C here, is sine alpha over A is here. Okay, and similarly, you can work on this one and you get sine beta over B is 1 over C. So this is sine alpha over A. That will be sine alpha over the opposite side is sine beta. Is sine beta here over the opposite side. This one, B, which is 1 over C. C is this side. But remember, gamma in this case, sine, here is 1. Why is what? Why is sine gamma? Is sine gamma, because sine 90 degrees is 1. Okay, so in either all those 3 different situations, you have this one. So that's basically proves the law of cosine. You just need to understand this lecture once, and then you need to do is to apply it. So later on, you will see more examples. I'll see you next time.